Hello, my students in grade 7. I hope you are all doing good. Last week, we continued inside the classroom in the school. I continued with your friends talking about what we still have in our lesson, the title Prime Numbers. What are the objectives that we covered last week? I reminded your friends again of the method of prime factorization. Then we found the least common multiple of two numbers, which we call it the LCM. We found the greatest common divisor or factor of two numbers, the GCD or the GCF. Finally, we talked about the relation between the LCM and the GCD of two numbers. I reminded them how we do the method of prime factorization. I will solve with you an example, which is the number 48. For the number 48, how can we decompose it into prime factors or prime numbers? I try if the number is divisible by 2. If the number is divisible by 2, I divide it. If not, I move to 3. If not, I move directly to 5. I do not divide the number by 4 since 4 is not a prime by 4 since 4 is not a prime number. So what are the prime numbers of 48? 48 is divisible by 2, so I write 2 here on the right side, and the answer is 24. Of course, as I said before, you can use your calculator to divide. Now 24 is also divisible by 2, the answer is 12. 12 is divisible by 2, the answer is 6. 6 is divisible by 2, the answer is 3. 3 is divisible by 3, it cannot be divided by 2, so the answer is 1. And as I said, the prime factorization finishes when the answer is 1. Now I should write here in this box the prime factors of 48. I count how many 2's do I have. I have 4. So I write 2 to the power 4, and I have 3 one time, so I write 3, which means 3 to the power 1. Also, these are the prime factors of 900. Then these are the prime factors of the number 64. Now, I have a number which is 900. The prime factors is 2 square times 3 square times 5 square. So how can I show that 900 is the square of number to be determined? So I should find a number whose square is 900. So I should take the prime factors of 900. When I'm talking about the square of a number, the exponent of the prime factors should be 2. Here the exponent is 2, here the exponent is 2, here the exponent is 2. So I here apply a rule of power that we learned before. I have different bases, same exponent. So I apply the rule, I multiply the bases, and I keep the exponent as it is. So after this, I find that 900 is the square of 30. So 30 square is equal to 900. Also 64, which is 2 to the power 6, I should determine it is the square of which number. If I look at the prime factors of 64, it has an exponent 6. It's not square, it's not 2. So how can I make this 6 as an exponent 2? I use the rule power of power. As we know, 6 is 3 times 2. So I write 2 to the power 6 is 2 square times 2 square times 2 square. So it is 2 times 2 times 2, which is 8 square. So 64 is the square of 8. Now, if I have two numbers, any two numbers, I can find their least common multiple. Let me remind you again of the word multiple. What do we mean by multiple of a number? If you multiply a number by any other number, the answer of multiplication is called the multiple. For example, if you multiply 6 by 2, the answer is 12. So 12 is a multiple of 6 and a multiple of 2. Here, if I have two numbers, each number has multiples. I can find the common between these multiples, the numbers or the multiples that are found in both. Then from the common multiples, I will find the least one, which is the smallest one other than 1, because 1 is a common multiple of all numbers. So I will let you see the steps that we use to find the LCM or the least common multiple of two numbers. First, I write the prime factorization of number 1. I write the prime factorization of number 2. Then from the prime factors, I choose the common base with the highest exponent and the non-common base. For example, if I want to find the LCM of the two numbers 72 and 90, I make the prime factors of 72, I make the prime factors of 90. If you look at these two boxes, which are the box of 72, the prime factors of 72, and the prime factors of 90, from these two boxes, you should choose the common base with the highest exponent. So 2 here is a common base because I can find it in both. Which one has the highest exponent? Here the exponent is 3, here the exponent is 1, so I take 2 cube. Here I have 3 square and the 3 square, so 3 is a common base. But I have the same exponent in both, so I take any one of them, so it is a 3 square. 5 is only found in the prime factors of 90. So it's not a common base. In LCM, I take the non-common. So the LCM between 72 and 90 is, from these prime factors, it is 2 cubed times 3 squared times 5, and I find the answer using the calculator, which is 360. Also, as each two numbers has multiples, each number has divisors, and I can find the common divisors of both numbers, and from the common divisors I will find the greatest common divisor. It is called divisor or factor. That's why I use GCD or GCF. It's the same naming. What are the steps to find the greatest common divisor or the GCD? It's the same. I write the prime factorization of number 1. I write the prime factorization of number 2. From both prime factors, I choose the common base with the least exponent only. Let me again do the GCD of 72 and 90. I will write the prime factorization of 72, the prime factorization of 90. From these prime factors, from 2 cubed times 3 square and from 2 times 3 square times 5, I will choose the common base with the least exponent. 2 cube or 2 to the power 1. Of course, I take 2, which is 2 to the power 1. 3 square or 3 square, when it's equal, I take any of them. 5 is not common, so I do not take it in GCD. So the answer here of the GCD is 18. This is a practice for you. You can practice this alone on a draft to understand it more. This is how I found the LCM and how I found the GCD. Now there's a relation between the LCM and the GCD and the two numbers. If I have any two numbers, A and B, and I found the LCM and the GCD of these two numbers, there is an important relation, which is, if I multiply the LCM by the GCD, its answer is equal to the answer of multiplication of both numbers. For example, if I have 72 and 90 and I want to find the LCM and the GCD, the LCM is 360. The GCD is 18. So if now I multiply the LCM with the GCD, the answer is 6,480. Now, if I multiply both numbers 72 and 90, the answer is also 6,480. So that's why I said that the LCM times the GCD of two numbers is equal to the multiplication of these two numbers. We have special rules to find the LCM and the GCD. These special rules are, if A and B are two numbers and B is a multiple of A, then the GCD is the smallest number, which is A, and the LCM is the biggest number, which is B. Let me give you an example. If you have two numbers, 5 and 20, you should find the GCD of 5 and 20. Since 20 is a multiple of 5, because 4 times 5 is 20. So the LCM is the greatest number, which is 20. And the GCD is the smallest number, which is 5. Now, if A and B are two consecutive or successive numbers after each other, for example, 6, 7, 7, 8, 8, 9, 20, 21, whatever are the numbers. Here, the rule says the GCD of the two numbers is 1 and the LCM is the multiplication of both numbers. For example, if I have two numbers A and B, 14 and 13, 14 and 13 are consecutive or successive. They come directly after each other. So their GCD is 1 and their LCM is the multiplication of both numbers 14 and 13, which is 182. If A and B are two relatively prime numbers, what do we mean by relatively prime? There's no common divisor between them. Then their GCD is 1 and their LCM is A times B, which is the multiplication of both numbers. For example, I have two numbers 9 and 17. Their GCD is 1 and their LCM is the multiplication of both numbers. These rules are very important. So we have three rules that you should memorize them to be able to find the GCD and the LCM directly without making a prime factorization. This was the lesson we covered last week. During the coming week, we will be solving exercises and I will send you the exercises we are solving in class to practice more at home. Thank you.